All right, let's talk about the third property in the ACID system. Isolation. Very, very critical and really underrated property. Not a lot of people truly understand the ramification of transaction isolation. So in this lecture, we're going to talk about isolation. And this is going to be a long lecture. So sit back, relax, grab a cup of coffee, tea, or your favorite drink, and let's go through it. So to talk about isolation, we have to answer this question. We have transactions, correct? And if it's a single user, that's fine, but we have many TCP connections to my database, if you support remote connections. And then each connection execute transactions. So there is a chance where concurrency can happen. Multiple transaction fighting over to write and to read the same pieces of data. And that's where isolation come into place. The question is, can my in-flight transaction see changes made by other transactions that are also in flight? That's the question that needs answering. Not only in flight, other in-flight transaction, even transaction that has finished. What if I am running a transaction and I'm querying, reading, and some other transaction committed a change? The question is, should I see this change? Well, it depends. Do you want to see that change? Right? There is no answer. There is no right or wrong. So as a result of these, you get a bunch of read phenomena, they call it, right? Very fancy name. And the main understanding of these read phenomena is these are usually undesirable. You don't want these. These are bad side effects, but we're going to go through them. We're going to understand what are they. And if you run into one of them, you're going to see and you understand, oh, now I see what's happening here. And these are one of the nastiest things to debug, in my opinion. We're also going to talk about isolation levels that were introduced to solve these undesirable read phenomena, right? So let's talk about isolation read phenomena. So what are these read phenomena? So the first read phenomena is called dirty read, and we're going to talk about them in details and with an example. But essentially, a dirty read is a read that you, as an in-flight transaction currently running, you read something that some other transaction has wrote, but didn't really commit yet. So there's a chance that this change that you just read could be rolled back, or it could be committed, or the database could be crashed, right? So this is called a dirty read. Anything that is dirty means that you wrote something and this write is not really fully flushed, not fully committed. It might change. And that's what is called dirty reads. Non-repeatable reads are reads that you are in a transaction, you read a value, right? And then in the same transaction, you read it again. And that sounds ridiculous. Like, what? Why would you ever read things twice? That's just dumb and inoptimal. But no, believe me, you do this all the time without you realizing. It's not about doing select ID from account and then doing select ID from the account. Not the same exact query. No, we're not talking about that. It's a little bit odd to do that, but there are cases where you actually do the same exact query. But I'm talking about the different queries that yield the same value, and there are thousands of these cases. And one example is you're gonna read a value, but then you do a select sum, which also reads the value behind the scenes because it does a sum. These are different values, but they are dependent on the same entry that is in the database. So an unrepeatable read is when you read something and then the database tries to read the same value again, that changes, right? And this is called a non-repeatable. It was not repeatable in my own transaction. So that's what a read phenomena. Some people find this undesirable, right? I'm going to show you an example of that. Phantom reads. Phantom reads are things that you cannot really read because they don't exist yet. I'm going to give you an example. So example with this is our range queries. Like let's say, hey, select all the activities between this date and this date, right? When you do this range between this and this, right, you get a number, right? You get a certain values. But then let's say someone inserted a new rows here. It's a completely new row. It's not really a non-repeatable read. You didn't even read it. It's just something that is inserted that satisfies your range query now. Now, if you do that and you do another select, right, you're going to get that phantom new row and you're going to get that read. And that things might go really wrong with that. And that's called phantom read. So you got certain result in the first situation, but the second one, you got a completely different result. So it's not really completely non-repeatable read. It doesn't qualify as a non-repeatable because you didn't really read it in the first place, right? You can't quite catch it. I'm doing this with my hand, but you can't see it. I'm doing this with my hand. The fourth one is really lost updates. That means I wrote something, but before I commit this right, I tried to read what I wrote. Well, this is very common because if you're on transaction and you write something and you turn around and read that something, that's completely fine because you are in your own bubble. You can read what you wrote, but other transactions usually can't. Depends whether dirty reads are enabled or not. But some other transaction can actually change what you wrote. So if you turn around and read what you just wrote, it's just lost. And that's called lost updates. We're going to talk about when that actually can happen and how to circumvent this. All right, dirty reads. Let's take an example. So we have a sales table here, and we have 3 columns: product ID, quantity, and the price. Product 1 has sold 10 quantities, and each is $5. So the total price is what? $50? $50. So we sold $50 worth of product 1. Product 2 is 20 quantity, $4. So the total is what? $80. So what is a dirty read in this case? You begin a transaction as usual, and you start this query. You select the product ID, and then the second column is an actually expression. You multiplying the quantity times the price because you want to see the total, right? From sales. That's generally a bad query. Not because we're doing an expression, but because we don't have a where clause. But we're explaining things here. So as long as I tell you that this is bad, because if you have billions of sales, now this is going through the whole entire table. You have to have always a range. You have to have a bounded query. I always say it's bounded. And the reason is it's unbound. This is an unbounded query. That means there is no bounds. It's just forever. It goes forever, right? Yeah, we have 2 rows here, but when things work with 2 rows, it doesn't necessarily work with 100,000 rows, right? But yeah, we got the idea, right? So we have what we're gonna get is a product 1 is 50 and the product 2 is 80, right? That's what we got. And this is the list. I don't know. Maybe I'm generating a report, a sales report. And now another transaction started while this is actually running. So these are in parallel now, right? So this started and this is now started. We selected this. We read the actual values that are currently in the table. Transactions 2 started, and right after this guy read the values, it actually made some more sales. Some people made some more sales on product 1. We added an extra 5. We sold an extra 5 products, right? So now what will happen is now it's 15. Okay. Now look at this. We're doing another query, but now we're just we want to sum all the sales, regardless of the products. What do you think the value should be versus what do you think the value will be based on a dirty read configuration? Look what will happen. We're gonna get 155. Why? Because if you multiply this 15 by 5 plus 80, which is good, this didn't change. So the original sum is actually 130 if you think about it, right? 50 plus 80. But we added a $25 worth of sales. So if you add that, you're gonna get 155, which is technically not wrong, but if you within the same transaction, this is inconsistent because if you actually print this in a report and you went it to the manager, says, okay, oh, product 150, product 280, and then you print it all the way down in the summary, you printed the sum as 155, they say, what are you doing? That's just wrong, right? And why did we do that? Because we read a dirty read. This guy didn't even commit, and yet we read the value. You notice that the line of the commit didn't even happen. Now we commit my transaction, which really didn't change anything, but we're just reading just to tell you that the transaction is terminated. But now this guy just, hey, you know what? Never mind. I'm going to roll back. Because, hey, we didn't really actually made five sales. Roll back. So no, this is actually worse. You read a dirty read, and that read has gone, right? And that is really a problem. You get an inconsistent result. So let's talk about non-repeatable read here. Same configuration here, 1050, 10.5, 24, and then we're going to begin a transaction. Now we're going to select the same exact thing. We're going to get product 1, 50, product 2, 80. So what is a non-repeatable read here? Another transaction begins, but look at that, the arrow is shorter. I made the arrow shorter. Why? Because here's what I'm going to do. This time, I'm going to make the sale, and guess what? I'm going to actually commit the change before the second transaction finish it, or before the second transaction actually made the second query to do the sum. Look at this. So we actually persisted. This is not a dirty read. This is an actual valid write and valid read. So the value is actually 15, but we read the value prior that change. So now, what should we do? Now I do a sum count price from sales, and guess what we're gonna do? We're gonna get the exact same wrong result. We get 155 when it should have been 130, right? That's the actual result that is desirable. So now this is not really a dirty read. This is an actual committed read, but the problem is this was a non-repeatable read because you read the values here and you read them kind of again, right? But you read them through an aggregation function, right? And as a result, you got an inconsistent value. And you might say, Hussein, in this case, I don't want non-repeatable read. Not all the time, because we're going to come to that. But fixing this is expensive. Fixing this so that you read always the same version of the value here is not easy. A lot of databases support it through MVCC, but it's not easy because now you have to keep a version of the product 1 at the original state. That's what Postgres does, by the way. Postgres always, any updates, creates a new version of the row. It never changes the same value. While MySQL and Oracle, and might be also MySQL Server, changes this, the final value, changes to 15, but it keeps another table called the undo, right? I'm writing undo here. I don't know if you can see it. But the undo stack keeps an actual writing to disk, a place where all previous values. Oh, product 1, by the way, it used to be 10, it turns to be 15, right? I don't know, it keeps the delta changes. So now, if this guy wants to read in Postgres, it will read the original version. It just keeps a version pointer here. So there is another row, product 1, version 2, right? Version B, for example, so you don't get confused. But in MySQL, what will happen is it cannot read this. It has to go and crack open the undo log and then read their values, and that could be expensive for long-running transactions, right? Because it cannot trust this latest value anymore. So yeah, this was just a short explanation of isolation, but we're gonna come to that. Yep, and then we commit, and obviously nothing changes. Bad. Non-repeatable read can be bad. So it really up to you guys. You cannot just go by this example and say, oh, I'm fine. No, really comes back to what are you trying to build, and then just understand this problem and say, hey, I'm fine. I'm even fine with dirty reads, because I don't think anybody's fine with dirty reads. Dirty reads is the worst. But I have actually built an application where I relied on dirty read, which was a very bad idea. I regretted that later. Let's talk about phantom read. So phantom reads result from range queries. Anything that can potentially give you one or more results. Pretty much, phantom read always happen, if you think about it, if you have a where clause. I can't think of an example where phantom read could not happen, to be honest. So same configuration, sales. We begin a transaction. We do a select quantity price sales. And this time, I'm reading this product, 50 and 80. Transaction 2 started. Now, it didn't really update. It inserted a new product, completely new product. Right? So now if you insert a new product, well, that's fine, because in this case, we didn't really read this product, but get this. It actually commits it. So now we have $10 quantity of product 3 at the price of 1. So an extra $10. So now what we do here in your original transaction, you're going to do a sum quantity from sales, which it doesn't have. It's an unbounded query. There is no bound to it. So that means we're going to, unfortunately, sum all of them include product 3. Yikesy. So we get 140. We should be 130. We read a committed value, nevertheless, not really dirty, and that just happened to show up in our range query. Okay? It's not really a non-repeatable read because we never actually read product 3 to begin with. In the previous one, we read these two values and they changed later. Okay? So, and why are we differentiating between these two? Is really the implementation when it comes to it. Like if you really want to know, your guys are interested, it just comes down to locking. In non-repeatable reads, when we read something, we want to guarantee repeatable reads. Anything that the transaction reads just obtains a shared lock on it. Not really a shared lock. It's one kind of locks. I'm going to talk about locks in this course as well. And then if it just makes sure that this read doesn't change for that transaction. That's what it makes sure of. But how does it get rid of new rows that has never been read? How does it get? You cannot even see the row to lock it to prevent it from changing. That's what phantom reads. You cannot grab it, right? It's phantom. So last update. Let's talk about the last read phenomena. So same thing here. We're going to begin two transactions in parallel concurrently. We're going to update one of these guys, update the quantity to increase to, let's say we added a $10 sale, 10 units of sales to product 1. Now, from 10, it turns to 20. Transaction 2 updated the same quantity to add 5. But guess what? This quantity now, it's reading the original value because they started at the same time. So both of them actually read quantity as 10. So this guy is also 10. So now what it will do is it will take the 10 plus 5 and then store it into the product. So now we have 15. So now we lost the value here. Okay? And that's what happens in this situation. So now we commit the transaction. Transaction 2 was faster. So it committed. And now we have the value 15. And now transaction 1 assumes that it made the sales. It will do the sum. And we're going to give you a completely different result that is absolutely wrong. Because it should have been 180. But we got actually less result. Why? Because our update was actually overwritten by another transaction, and as a result it was lost. One of the nastiest thing. And this can be solved basically by actually locking the row. So hey, if someone row level locks are very popular here, we're going to talk about them here. It's like, hey, I just changed this. I don't want anyone else to change the same row. There's no point of it. Let me finish and then release it, and then once I'm done, you go your own merry way. All right. We talked about read phenomena. We need to talk about isolation. I know this lecture is a little bit long, guys, but there's a lot of information here. Feel free to ask questions and to understand this better. So isolation levels for in-flight transaction. What are they? So we're going to talk about many isolation levels. That were invented to fix those read phenomena that we talked about. So when I try and start my transaction, you set this isolation level. using keyword, I believe, set isolation level, literally in a transaction. This is the SQL command for it. So, hey, I want to start a transaction with read uncommitted. That's the first one, which I believe no database supports except SQL Server. Read uncommitted just means no isolation. I want to read anything you read is visible by anybody outside that changes this value, right? It just read uncommitted is related to the transaction itself. So it means no isolation. Any change from outside is visible to the transaction, whether it's committed or not. That's what's called read uncommitted. You can read uncommitted values. As a result, you can get dirty reads here. Bad, obviously. But if you think about it, it's technically fast, right? Because I don't really need to maintain anything. It's questionable because the implementation, you don't know what the implementation is. You just assume from theory that it's fast, but could be not. Read committed. This isolation is one of the most popular isolation levels out there. And so a lot of databases optimize their engines for read committed workloads, which means each query in a transaction only sees committed changes by other transaction. And we talked about that in the examples, right? So now if there's a transaction that makes a change, right, while I'm reading something, I'm not going to see this change unless the transaction commits it. Once it's committed while I'm still running the transaction, I'll be able to see that change. You might not be happy with that. You say, hey, this could get inconsistent, but just understand that this exists. And I believe this is the default isolation level for many databases. Just understand that if you have a long-running transaction, anything that has been committed will be picked up by a transaction. This could be bad. Repeatable read, which is the isolation level, was invented to fix the non-repeatable read. Right? Non-repeatable read is just bad read phenomena. Repeatable read is the isolation level to make the read repeatable. That means as I read and I read it again, it's not going to change. I can read it 1,000 times. As long as I'm in the same transaction, the value will not change. Let's read this definition. And by the way, I rewrote this definition based on my understanding. You will not find these definitions in the web because, frankly speaking, computer scientists always complicate things because they added a lot of jargon for some reason, right? So based on my personal experience and professional experience working since 2005, this is what I give you. I give you things that are practical, that you can touch and feel. Right, fix the typo there here. So the transaction will make sure that when a query reads a row, that row will remain unchanged while the transaction is running effectively, right? So that's what it means. Only when the transaction actually reads a value, reads an object, reads a row, reads a column, then we're gonna make sure that as long as this transaction is running, that value will never change. But if you didn't run it, if you don't read it, we're not gonna copy a version of that row. If you get my point, right? Because how do you implement something like that? Think about what the database is doing for you. There is cost for everything, and this is a cost. If you can take a snapshot of the entire database if you want, and that's another isolation level, by the way, called snapshot, right? But that's also expensive. There's the thing, snapshot. Each query in a transaction only sees changes that have been committed up to the start of the transaction. It's like a snapshot of the whole database at that moment. This is guaranteed to get rid of every read phenomena. This repeatable read doesn't get rid of phantom reads because we saw that phantom read just sneaks in. It's an insert. We never actually read a value to lock it or to obtain some sort of a lock so that we can version it. We didn't even get to do that, right? Snapshot isolation this is what I read at that stage. And Postgres repeatable read is actually a snapshot isolation. It's just everything versioned. So if you start a transaction, you kind of timestamp which version you are in. And then as a result, you're always going to read this version. So even if new inserted rows show up, you will not pick them up because the database will filter things based on your version effectively. And that's the power of the snapshot isolation. The final one, or basically the slowest, if you think about it, is serializable. That means there are no concurrency anymore. Just each transaction is almost physically, database is implemented differently, but as if they are serialized after the other. So if there are 3 transactions started at the same place, they will be serialized based on, now this depends on the linearizability and stuff, complicated stuff like that. Which one goes first is the question that the database tries to answer so that you get almost the same results. And obviously, I talked about that. Each DBMS implement isolation level differently. Don't over stress with these isolation levels. Just understand that they exist. Most of the time, you're never gonna run into these complex situations. But if you do, know that these things exist, especially with a lot of users changing and reading at the same time. This is when you need to know about this at least. I took this from Wikipedia. I like this table a lot. It doesn't have the snapshot isolation, but if you look at this, you can see that read uncommitted, everything may occur. With all the read phenomena occur. This read committed, everything can happen except dirty read. You cannot get dirty read because, hey, I'm reading committed stuff. Repeatable reads, you don't get dirty reads, you don't get lost updates, and you don't get non-repeatable reads as well. All right, because we fixed that with repeatable read, but you still get phantoms. But in serializable and also snapshot, you don't get any of this. It's all fixed effectively, right? And there is a slight difference between serializable and snapshot, right? Serializable is effectively just slows things down if you think about it, right? Because it just serializes things, while snapshot takes a version of the database at the start of the transaction. Now, when I say a version of the database, I'm not talking about actual backup, right? It's the database have to implement this in a optimized manner. Make sense, guys? Let's talk about a little bit of database implementation of isolation. Each DBMS implements isolation level differently, of course. There is the pessimistic approach, which is this means the pessimistic concurrency control. To be specific, it means I'm going to use locks, and I'm going to dedicate an entire section lectures talking about locks. When you get to that, you're going to learn more about it. But effectively, I'm going to obtain our row level locks, table locks, page locks. Table locks, that means any change I make, I'm going to obtain a lock in the whole table. Very, very expensive, by the way. I run into a lot of situations where my transactions lock the entire table, called lock escalation. It's escalated the row to a table lock, and then all transactions were just pending, trying to change other values, and it couldn't because the table was locked. Page lock, the actual logical page that contain the changes are locked. This is especially true in case of clustering. If you want to cluster your table, again, we're going to talk about that as well. And then these pages that you write to also have certain locks. So effectively, there's a pessimistic approach. Lock, hey, I'm changing, lock it. Don't let anybody touch this. So if you lock a row, only that row won't be able to touch it. You're going to see some examples when I showed in Postgres and MySQL that when we try to update something, it will succeed, but another transaction will try to update, it will just sit there and wait because the row is locked. Optimistic usually don't use locks. That's the other approach. That means there won't be any pending transaction. So also, not only that, so nobody will wait on the other. And also, the benefits of this is the lock management, which is extremely expensive, by the way. Because how do you know that a row is locked? You have to maintain it in memory, right? You have to keep track. The database has to keep track. Oh, this is locked. This is not. This is locked. This is expensive, especially row level locks. If you have like 700,000 rows that you need to lock, this is expensive. So optimistic, a lot of people prefer this approach, where, hey, I'm not going to obtain an actual lock, but I am going to just let things play by ear. And when when transactions start stepping on each other, boom, I'm going to fail the transaction. And the user should just retry. And the error is called usually a serializable error. You get, it's like, hey, something changed at the beginning of the transaction, so just retry the transaction. NoSQL databases prefer this approach to locking, because locking is expensive. Repeatable read locks, I talked about that a little bit. Repeatable read locks the rows it reads, but it could be expensive if you reads a lot of rows. Postgres implements repeatable read as a snapshot. We talked about that, right? Snapshot and repeatable read in Postgres are identical. It's the same thing, right? This is why you don't get phantom reads with Postgres in repeatable read, where in other databases you get phantom reads with repeatable reads. And spoiler alert, that's part of a quiz. Serializable are usually implemented with optimistic concurrency control. Because if you actually truly do serializable, then your database is gonna be so slow, right? Because what is serializable? Just one after the other, right? So that's why a database is implemented with optimistic concurrency control. You can also implement it pessimistically if you want to, with select for update. Hey, I'm gonna select this, but I'm gonna lock it. Right, that's what you do. So let's summarize the isolation. Isolation is the result of having the transaction run in complete isolation from other concurrent transaction. As a result, we get read phenomena, and we have a lot of isolation levels that have been invented to fix read phenomena. Let's jump to the next lecture. Good job, by the way, finishing this lecture. Good job.